Let's read chapters 3 to 6, which is part 2 of Clean Architecture by Robert Martin, aka Uncle Bob. In the intro to part 2, I really liked his definition of a coding paradigm. He says paradigms are ways of programming. They tell you which programming structures to use and when to use them. I think that's a great definition of a paradigm. And in this part, he looks through the major programming paradigms, starting with structured programming, OOP, and functional programming. This book gave me a whole new respect for Dijkstra, which previously I knew he was the guy with the algorithm. I didn't realize he was the father of structured programming. I don't like these one-sentence summaries. I think they're not very good. Do continue to read the whole chapter to dive deep in what OOP means to him. Same with functional. These one sentences are not that good. Here was a nice point. Bob argues these three are the only paradigms we're likely to see because they involve removing pretty much all of the coding fundamentals, so you can't really remove more than that. I thought this was a good point. Structured programming, there was some good historical info in here. Fun fact, Dijkstra was Dutch and said that he's a theoretical physicist because the Netherlands wouldn't accept his title of programmer. I think this further goes with the idea that programming is similar to construction, pushing back on the forward. Additional historical context gave me a good respect for Dijkstra, but the TLDR of structured programming chapter is don't use go-to statements. And we basically don't use that in modern programming anyway. Some good detail on why not to use go-to statements and functional decomposition. This was a great section. I mean, we love to break our code down into modules instead of giant monolithic scripts. And this was really cool where we start saying that we're not going to do full proofs of our code. We're going to use the scientific method instead. Really like this section. So when we write unit tests, these are not formal proofs, but they are attempts at falsifying the system. And we can do these from the unit level all the way up to the system level, the architectural level. The chapter on OOP, I thought it was fine from a historical context example, but I really don't like this definition. And this is not specific to Bob. I always have problems when I get to OOP. I haven't seen a good definition yet. Encapsulation is not specific to OOP. We love encapsulation in functional programming as well. Inheritance, okay, you can have that one. It's possible without OOP, but definitely OOP enables this. And I don't see that as a good thing, especially when you get to multiple inheritance. I think that's a trait of dirty code. The implicit code there, it's a trap, right? Polymorphism, the way he talks about the benefits of polymorphism, I wish he would have just said strong types and interfaces. So he acknowledges that perfect encapsulation exists in non-OO languages. And he agrees that actually OOP weakens encapsulation. He says Python and JavaScript are OO languages, which I disagree with. They're multi-paradigm, not OOP. So multiple inheritance, fine, OOP can have it, but that's not a good thing. For instance, in a real OO language, upcasting would be implicit. That's a bad thing, we don't want this. So you can call that OOP if you want, so stay away from OOP then. He agrees you can do polymorphism without OOP, but he says it's dangerous to use pointers to functions. The idea here is that you could reassign the pointer and it would be hard to debug. I only think this is dangerous if you're missing a type system or strong types. So in a JavaScript, this might be dangerous, but in a TypeScript, I'm not seeing how it's dangerous. You have interfaces, you can guarantee the interface. So if he's using OOP loosely to include things like TypeScript, fine. I actually think he is doing that, but I think it's wrong to do that. TypeScript is multi-paradigm, it's not OOP. So again, he talks about polymorphism, but I wish he would have just said strong typing or something like that. And then he talks about dependency inversion, which we usually call dependency injection or inversion of control. Again, this is not specific to OOP. Maybe as a matter of history, this pattern rolled out with OOP languages, fine, but you can do DI with an immutable context or a store. We do that often in React. Callback functions are not new. So he might be speaking in broad strokes and then that's fine. I think it's nice for the history. OOP doesn't give you absolute control. That's misleading. So it was good for the history, but in terms of technical information, I think he really missed it. And we continue into functional programming, and he really misses a lot of the value of functional programming. He calls out immutability. That's fantastic and true. Let me just skip to the end of the chapter, though. He misses some really big ideas in functional programming, like the absence of side effects and reproducibility. So agreeing that we like this scientific mental model of target and optimal architectures, reproducibility and replication is fantastic for science, so we should embrace that. Explicit over implicit, he doesn't really talk about this, right? That's a huge benefit of functional. And then composition over inheritance, he doesn't talk about that either. So these are some of the big themes of functional that are unfortunately missed in this discussion. That does it for part 2. Follow along as we continue.